Okay, problem 1 says, this hydraulic lift is designed to lift a 3,000-pound car. The diameter of the cylinder under the car at piston 2 is 3 feet. The diameter of the cylinder at piston 1 is 6 inches. So 3 feet and 0.5 feet. And the reason I put it in feet, the 6 inches, is because down here it's saying what is the area in square feet of the circular surface of each piston. So I wanted to get that in feet. So let's do the area of piston 1 first. Area of piston 1 is equal to, that's a 1 by the way, pi r squared. And it does say to use 3.14 as, this is a 1. It says use 3.14 for pi. So our area of piston 1 is going to, that is a 1, not an r. The area of piston 1 is equal to 3.14. And for the radius, I'm going to put 0.25 because 6 inches is a half a foot, is 0.5 feet. That's the diameter, however. I need the radius, so the radius is half of that, which would be 0.25 feet, right? It would be 3 inches, and 3 inches is 1/4 of a foot. So it's going to be 0.25 inches squared. And that means that the area of piston 1 is 3.14 times 0.25 squared is 0.19625, so let's just say 0.2 feet squared. Okay, and honestly at that point I could stop right there because that's piston 1 and there's only one answer on Kite that has that. But if I wanted to work this problem out, because you will notice that they actually have two answers that are very similar. One that has 0.2 feet squared as the second answer. So be careful when you're doing your math and pay attention to which one is which. So the area for piston 2, likewise, pi r squared. Area of piston 2 is going to equal 3.14. That's a 4. Sorry, it's hard to write with this. 3.14, and radius here is going to be 1.5 because the diameter is 3, and that's already in feet. And 3.14 times 1.5 squared is 7.065, so let's just say 7 feet squared. So the area of piston 1 is 0.2 feet squared, and the area of piston 2, 7 feet squared. Okay, next problem. The hydraulic lift is designed, so same lift, 3,000-pound car, so 3,000-pound car is going to be important in this. The diameter of the cylinder under the piston under the car is 2 feet. So it says how much pressure in pounds per square foot, so PSI, does piston 2 exert on the hydraulic fluid? So this fluid is stuck in this system. And if the car is pushing down, so the car is 3,000 pounds, and the piston is 6 inches in diameter, okay, then we can also figure out that the area of that piston is 7 feet squared. And if we know that, okay, then we can do 3,000 divided by 7. And we get 429 pounds per square foot. And the key here is going to be, look, you have to pay attention, in pounds per square foot. That's why I kept this in, that's why I kept this in feet. Actually, this is not 6 inches, this is 3 feet, apologies. So the area is 7 feet squared. So I used feet, not inches, to give me pounds per foot squared, right? Pounds, if this is feet squared and this is pounds, then my answer is going to be 3,000 pounds divided by 7 feet squared gives me 429 pounds per foot squared. If it were asking me for inches squared, I would need to have converted this 3 feet diameter into 36 inches and used a 36-inch diameter to find area, and then use that area in this problem to find inches squared. Be careful on this problem because one of the possible answers on my PLTW is 429 pounds per square inch. Please be careful. Realize what it is, the units are that you're using in your problem to know what units you're getting in your answer. Make sure you select the correct answer with the correct units that match your answer, but also make sure that the units in your answer match what they're asking for, which is in pounds per square foot. Okay, next problem. How much work does piston 1 do to lift the car 2 feet? Okay, well, how much work does piston 1 do to lift the car 2 feet? Okay, well, if at the output, so where the car is, we have a force times distance, and we have 3,000 pounds, and it's moving 2 feet, then it's 6,000 foot-pounds. Okay, so work equals force times distance. Okay, the next problem requires that we apply a little bit of knowledge about Pascal's law. And Pascal's law says that the pressure inside of this system, so everywhere this yellow fluid is that's pushing, is equal everywhere inside of here. So we can find out how much pressure there is here because we have a force, right? So if we say the output, let's say the pressure at the output, okay, is going to be equal to force at the output divided by the area of the output. So the pressure at the output is going to be 3,000 pounds divided by the area of the output. Remember, the area of the output equals pi r squared. So the area of the output equaled 3.14 and times 1.5 squared. So we needed the radius. So the area was, I believe we said it was 7 squared. Confirm that really quickly. 5 squared. Yeah, 7.065. So the area is 7 feet squared. So if we know that the area is 7 feet squared, then we can say that the pressure at the output is, and we've done this problem previously, is about 429 pounds per foot. Okay? So if we know that the pressure here is that, okay, then we know that mechanical advantage, okay, is equal to force output divided by force input. Well, we know that the force output is 3,000 pounds because this thing is lifting 3,000 pounds. What we don't know is the force being applied here. We don't know. What we do know, though, is the diameter of this piston. So if we wanted to know the force at the input, we could do pressure times area. So so we could do pressure at piston 1 times the area of piston 1. Now, reminder that piston and area need to be in feet there. So we're going to do the pressure. Now we know that the pressure is going to be equal throughout the system. So the pressure in the system was 429 pounds per foot, so 429. And the area we can find. So we have 6 inches. So the area is going to be 3.14 times, not 6 inches is a half a foot, but we need half of that, so 0.25 squared, and 0.25 squared times 3.14 is, we'll say, 0.2, so it has an area of approximately 0.2. So 0.2 times 429 is 85.8. So the force being applied at the input is 85.8. And when we do 3,000 divided by 85.8, we get 34.96, or let's just say 35. And remember, mechanical advantage does not have units. Last problem here. The main line in a hydraulic lift has a leak and needs to be replaced. What diameter does the new line need if the flow rate is 2,500 cubic inches per minute and the flow velocity is 795 inches per minute? This is really quite easy. If you look under fluid mechanics on your formula sheet, you will see this formula, Q equals A times D, where Q is equal to flow rate. So our flow rate, it tells us, is 2,500 inches cubed per minute. And it says a flow velocity. So flow rate is a volume. It's how much of a liquid moves at a certain amount of time, whereas the velocity, which is V, is how fast, so how far it moves per unit of time. So in this case, it's telling us 795 inches per minute. So we have 2,500 cubic. Okay. So to find the area, we're just going to do Q divided by V equals A, and in this case that's 2,500 divided by 795. And that should give us an area of 3.14. So if the area is 3.14, and we know that area is equal to pi times r squared, we can divide this side by pi, divide this side by pi. 1 equals r squared. Take the square root of that, take the square root of that. And we find that radius is equal to 1, but it's asking us what the diameter of the line is. The diameter is 2